Okay, I think we're live now.
Okay.
All right. So the first question on the preparation assignment, classify each of the following batting averages as either unusual or not usual, or not unusual. Use a z-score to make this determination. And the first one is 0.19. So would that be unusual or not unusual?
Well, when we get the z-score, it gives us minus 2.088, so that's unusual because
Right,
yeah, it's bigger than 2, independently that it is a negative number, right?
right.
Okay.
The next one is 0.225. That's not unusual. The z-score is 1.059. That's what I got, and that's the answer key also.
Okay, yes, that's what I got too, so not unusual. And for the other question, 0.325, the z-score gave me 1.882, so not unusual, right?
Correct, correct.
Okay.
And the last one is 0.335. The z-score is 2.176, so that's above 2, and that's unusual.
Unusual. Okay, great. Okay,
Okay.
question number 2. It says find the probability that the randomly selected professional baseball player will have a batting average that is greater than 0.335. So the probability that the batting average will be greater than that number for me is 0.015.
That's right. Yeah, that's the same thing I got.
Okay.
The next one, we got provide a brief description of a normal density curve. Describe the shape and the properties. So the normal density curve is symmetric and it has a bell shape. It is also determined by its mean and standard deviation.
Okay. Yeah, great. Number 4, in the following z-score formula, z equals x minus u. It's like I don't know what. Well, that sign divided by the standard deviation. It says please state. Well, u is like the mean, right?
Right, that's mean.
Okay, divided by the standard deviation. Please state what each symbol stands for. Well, I already told you two of them. Well, z is how many standard deviations away from the mean,
Right.
the observation wise. The x is the observed data point, and then the like a u. I don't know how is it
I
called
don't know the
that
name of that symbol either, so
symbol. So that's the
Great.
mean.
Yeah.
And like the other symbol is like a no. It's the standard deviation. But I
That's
don't know the name of those symbols.
neither. Okay. So number 5, in no less than 3 sentences, please define and describe the 60, 68, 95, 99.7% rule. Well, it took me a lot of time to digest this information, but I'm just gonna try to read all out what it's already here. So it says that for any bell-shaped distribution, it's a
Mm-hmm.
60% of the data will lie within one standard deviation of the mean. Then
Mm-hmm.
95% of the data will lie within 2 standard deviations from the mean or off mean. And 99.7% will lie within 3 standard deviations of the mean. That's why it is called 68, 95, 99.7%.
Okay. Yeah. That's a good rule if we want to get a number, well, like an approximation. And then luckily we have the calculation, well, the formula, I don't know, which was given to us, that is where we can calculate the z-score in the area. So that's,
Right.
yeah, it's better. Let me read the other question, and it says then number 6. Well, here are two problems: GRE scores and speed of hydrogen. I don't know. I don't know how to pronounce that. Well, 6. The mean of all quantitative scores on the GRE is 150.8 with a standard deviation of 8.8. The scores of the quantitative proportion of the GRE are approximately normally distributed with mean. Well, like we said, the mean is 150.8, and the standard deviation, which symbol looks like an O, is 8.8.
Right. Correct. Then it says, what proportion of the people who take the quantitative portion of the GRE will score above 165? That's well, it has a bunch of symbols also, but it's 0.0533.
Okay, great. Let me read the other question. It says, if a student's score is in the 10th percentile, what would their corresponding z-score be? Well, for me it was easy if I use the I don't know, it's like an applet. That's an application we were given.
Right.
So I just entered the number, and it got easier for me. And I got minus 1.2816. And this is not an unusual number because it is not greater than 2.
Okay, I agree with that. So the next one is letter D. It's what is a quantitative GRE score for a student who scores at the 10th percentile? And that's on GRE score equals 139.5, and it's rounded up to 140.
Okay. And number 7, it says the mean speed of hydrogen, or how is that pronounced? Hydrogen?
Hydrogen?
Hydrogen at room temperature of 1800. That's like, M is like what?
That's minutes, is it? No, I don't know, meters? Yeah, meters.
I don't
is it?
know. Meters
I don't even know.
per second?
I don't even know.
No.
Yeah,
Well,
I think so.
well, with the standard deviation of 600, let's just say that. At room temperature, the mean speed of hydrogen H2 particle is approximately normal with a population mean, well, like it says above, 1800 meters per second. Meters per second, it says. And
Okay.
a standard deviation of 600 meters per second.
That's right. So letter B, it's what is the probability that a randomly selected particle has a speed over 2,500 meters per second? And that is 0.1217.
Okay. And the next one, it says, what is the probability that the randomly selected particle has a speed that is less than 2,500 meters per second? And here I have 0.8783.
That's right.
Yeah, I did it by subtracting the answer you gave me, 0.1217.
Okay. Letter D, it's what is the probability that a randomly selected particle has a speed that is less than 1,500 meters per second? And that's 0.3085.
Okay. And let me go to the next one, and it says What is the probability that the randomly selected particle has a speed that is between 1500 and 2500 meters per second? And I got using the applet 0.5698.
Yes.
Okay.
Last one is, what is the third quartile of the speeds of hydrogen at room temperature? And that is third quartile of the speeds of hydrogen equals 2,204.4 meters per second.
Okay. And then we have to answer the other questions about the
Q plot.
yes. So plot A, oh, sorry. Plot A, it looks like not, for me, it's not normal. It's like a curve there. So,
Yes.
and the points are plotted separately. So for me, not normal.
Is not normal. And also, well, plot B as well is not normal.
And plot C, it looks like normal.
Right. And I think plot D looks like normal also.
Okay, and let me see plot E. Well, no, that's like a curve. Well, no, not normal for me. Like a víbora. I don't know.
Plot
In
F,
English.
plot F looks like normal.
Oh yeah. Okay. So what's the name of a víbora?
A snake?
Ah, yeah, snake. That looks like a snake. I'm sorry. Okay.
Okay. Okay, I guess we're done.
Yes, I guess so.
It's a hard topic, so I guess I'm gonna keep on studying a little bit more on this.
I hope we can use the applet.
Yeah, it helped me a lot when I used the applet. I couldn't use it
Yeah.
from my work computer, so I had to do it from here from my home.
Okay, because we have an exam like in 2 more weeks.
Oh my, okay.
So I don't know if we're going to be able to use the applet.
I think
Okay. I hope so.
so. Okay, let me stop broadcasting, okay?